Okay, I believe I'm live. All right. So, okay. So I will be studying linear algebra right now. I did first part of linear algebra um just few hours back, and I will be doing second part of it, and I will be solving. Uh, I do have some physical books. I will be solving questions from that, uh, maybe today or properly tomorrow. Tomorrow we will. I will try to have a session where I will just solve solve questions from linear algebra itself, from matrices, vectors. That's my plan. And okay, let's see if this plan actually works or not. Um, all right. So let me just start this. I will bring this PDF to the other page. So basically, in this session, I am going to solve system of equations. It is fairly on the easier side as compared to matrices, but uh, people use it at various places. All right, like when we will expand the lapis, like I don't know how to pronounce it, but yeah, in that expansion, matrices will be used a lot, and by a lot, I really mean a lot. Okay, so these are four fundamental things that I will learn today. Okay. I think I can just start it. Okay, I will play this on 1.5, probably. Yeah, 1.5. Okay, and maybe starting will be a
Something that we
little
used to
slow.
discuss in our primary -1.
So let me first just read through PDF. If I am understanding things, I will skip the things. So if they are, let's say, three equations, okay, not even three, they are only two equations. And if we have to solve this equation, what we can do. Okay, so basically they are he's trying to eliminate the things. uh, I don't know, let's just see the video first, then I will get the clarity. Okay.
4, 8, -8. And then x, y equal to 2 equations, right?
Yeah, yeah.
So it may be x plus y equal to 8 and x minus y equal to, let us say, 12, right? So anything. So here it is like an equation in two variables. Similarly, when you had three variables, right, x, y, and z, you need three equations to solve this, right? So for example, if we take an easy example, right, let us say x minus y equal to 2 and 4x minus 8y equal to 0. So how do you solve this equation, this kind of equation? There are various techniques, right? Substitution method, elimination method, and all. So let us discuss one of those methods today. So what we can do is that uh, this is the equation, right? X minus y equal to 2 is one of the equation, and then 4x minus 8y equal to 0 is the another, right? Now, what we can do is this is equal to if you see this equation, this is nothing but 4x minus 2y equal to 0, right? 4 cannot be 0, so x minus 2y is 0. So the two equation is nothing but x minus y equal to 2 and x minus 2y equal to 0. Then what you can do is that you can put a minus sign over here and a plus sign over here. So basically you are subtracting the two equations. So what you get is you can subtract x and x, which you will be getting 0, and then 2y minus y, which is y, and then you get y equal to 2, right? Now if you put y equal to 2 in one of these equations, you will get the value of x. So this is kind of an elimination technique where you eliminate one of the variable, right? And this has its
So this is basically the basic algebraic equation that we used to do in 7th 8th grade. It is like, yeah, same as that. So okay, should I do this um in the in my workspace? Okay, let me do it. I don't know if it's visible or not. Probably not, because yeah, that screen isn't visible. Okay, no issues, I will just do it. um, so let's say here we have x minus y equals to 2, and then 4x minus y minus 8y equals to 0. So what we can do here, so he went like this, he excluded 4, then this would be x minus, yeah, this would be 2y, and this is x minus y equals to 2 equals to 0. So in this, if we solve this thing like in a algebraic form, then it, okay, I will just move this to main screen. Yeah, so if I'm willing to solve this with x minus 2y to 0, so sign will get inversed here. So this will be y and this will be 2. That's it. It will get cancelled out. It's positive, it's negative, it will get cancelled out. Fine. If this equals to 2, then we can easily solve this. Yeah, makes sense. Or else we can do, uh, let's say, multiply this whole thing by 4, and you can get the value from this too, like 4x minus 4y, and then we put it in the equation. We'll get the value from this angle too. Let's just see how 4x minus y equals to minus 4y equals to 8, and y equals to 0. And if we need to cancel out, then minus plus, okay, this got cancelled out, and this came to 4y equals to 8, and this comes to 2 again. So yeah, simple as that. Nothing much to do. You can move ahead. Okay, so he deployed it uh, in matrices form.
So what we have necessarily over here is 1 minus 1. Okay. So now let us represent this matrix equation in form of matrix, right? 4x minus 8y equal to 0. So just observe it. So what we have necessarily over here is 1 minus 1, 4, 8, minus 8. And then x, y equal to 2 and 0. Right? So this is how we represent this form of system of linear equation in form of matrix. Now if you multiply these two matrices, right? Let us see what will you get if you multiply these two matrices. I have discussed the matrix multiplication in the last lecture only, right? So how do you multiply these two matrices? So first of all, this is 2 into 2 matrix, and this is 2 into 1 matrix, right? So the matrix.
Okay, let's just multiply this and let's see what result uh, we can fetch over here. So we have to multiply. So basically, it will produce a 2 into 2 matrix as a result. So let's just see how it goes. Okay. um so 1 minus 1 and 1 minus 1 and 4 minus 8. Okay, so first column into row we can do. We have to fill this 4 places. Let's say, and for this I have to do um, first column into row, then it would be x minus of, is it same now? Let me just figure it out once. Yeah, we just have to plus the, I just have to add. Okay, so from first we get x plus um, we will get x minus y at answer, I believe. uh, but how? Let's just see how. Okay, so x plus, it will be minus y. So if we are multiplying minus 1 into y, it's basically minus y. So we got x minus y over here, and at this place we will get okay. Actually, what I think, uh, the matrix was 2 cross 2 and the other one was 2 cross 1 now. So if, so it would be 2 cross 1 matrix, so it will be just like this. We figure out 1 x minus y, we just have to figure out the second thing. So that would be 4x plus minus 8y. So 4x minus 8y. So this is equals to 2 and 0. Yeah, I think so. Yeah, so basically x minus y equals to 2 and 4x minus 8y equals to 0. That's it. Yeah, can we just move ahead? Okay, I solved this thing. Same answer. So if there are three um, equations, how we gonna solve this? So it will fall into the same category, na? So I don't think there should be much problem. Okay, I have to really figure out if this is something I wanna do.
one of the variable and then take the first equation and eliminate the second variable as well. So you will be having an equation in one variable, then you find the equation value for that variable. Similarly, you will be proceeding. So do I need to show it how to find the value of x, y, and z? Anyone there? You can tell it and I will be doing it. Otherwise, you can try doing it by yourself. Okay. So what will be the matrix form of this equation? Okay, and first of all, why are you doing it in matrix form? Because here you are having 3 variables, right? What if you have 10 variables? What if you have 100 variables, right? That's why you need it in quantitative finance. So when you will be doing finite difference method for options pricing or derivatives pricing, there you will be having around 100 variables, 120 variables, 200 variables, right? So therein you can't solve it manually. Manually in the sense elimination technique, substitution technique. It will be difficult, right? So therefore we need a consistent method to do it, and that is why we need the matrix form, matrix method to do it. Okay. So how will you be writing it in the matrix form? Just very simple. Write the coefficients first. So 2, -5 and 3, then 3, -1 and 4, then 1, 3 and 2. Okay. Then in a column matrix write the variables. So we have variables x, y, and z. Okay. On the right hand side write whatever is in the right hand side of the linear equations, right? So 8, 7 and -3. So this is the matrix form of this particular linear equation. You can just multiply these two matrices and cross check. I think I will leave it for your homework or assignment. Just multiply these two matrices and check whether you are getting this linear equation or not, right? Or it's quite easy to do it, right? Because it is just first row and this column, this row and this column, and this row and this complete column, and so you will be getting this system of linear equation only. Any doubt so far?
No.
Okay. So let us proceed first. So what is the matrix form again? If I repeat it, what is the matrix form that we got? These 3 things are matrices only, right? So we can write it as matrix A. Okay. You can write this particular matrix as matrix B, for example, and we can write this matrix as B. Okay. So this is matrix A, this is matrix B, and this is matrix B. Okay. So what you are having is matrix A multiplied with matrix B, and we are getting a matrix B. Okay. Any doubt so far? And basically, this matrix V is the matrix of unknown, right? So if you know what matrix V is, for example, if somehow you got to know that the matrix B, so what, first of all, what is matrix B? This x, y, and z. If somehow you are able to find out the numerics, for example, let us say 8, 9, and 10, then basically you are done. You are done with the values for x, y, and z. The value of x will be 8, the value of y will be 9, and the value of g will be 10. So our goal is to find out the value of matrix V. Okay. So let us see how matrix V. Any doubt so far? And basically, this matrix V is the matrix of unknown, right? So if you know what matrix V is, for example, if somehow you got to know that the matrix B, so what, first of all, what is matrix B? This x, y, and z. If somehow you are able to find out the numerics, for example, let us say 8, 9, and 10, then basically you are done. You are done with the values for x, y, and z. The value of x will be 8, the value of y will be 9, and the value of g will be 10. So our goal is to find out the value of matrix V. Okay. So let us see how we can do it. Okay. So this is the first technique that we will be discussing right now. Okay. So just do one thing. Can we multiply this A inverse? So we can write A inverse equal to A inverse, right? And then we can multiply both sides with, so we can multiply this side with AV, and we can multiply this side with V. Will it be any problem? Because AV and V are equal, right? AV and V are equal, so there is no problem in multiplying, right? Both sides.
Yes.
Okay. And what will be A inverse into A? Can anyone say?
Identity matrix.
Identity matrix, right? And here what? So we can multiply this side with AV, right? A inverse equal to A inverse, right? And then we can multiply both sides with, so we can multiply this side with AV, and we can multiply this side with V. Will it be any problem? Because AV and V are equal, right? AV and V are equal, so there is no problem in multiplying, right? Both sides.
Yes.
Okay. Equal to A inverse V. So what you have is V is equal to A inverse multiplied with V. We already have the matrix A. So first of all, what we need to do is we need to find out the inverse of matrix A, and that is on you. Please do it rapidly and tell me what is the inverse of matrix A. Matrix A you already know, right? So you need to find out the matrix inverse of matrix A. So you guys need to tell me what is the inverse of matrix A. Either you do it using a built-in library or you do it manually, but please tell me what is the inverse of matrix A. If someone has access to Python, they can just do it in Python and let me know what is the result. Or if you are doing it manually, of matrix A. Either you please do it rapidly, equal to A inverse, being A inverse and B. Identity matrix multiplied by any matrix will be that matrix only. So it will be V equal to A inverse B. So what you have is V is equal to A inverse multiplied with B. We already have the matrix A. So first of all, what we need to do is we need to find out the inverse of matrix A, and that is on you. Please do it rapidly and tell me what is the inverse of matrix A. Matrix A you already know, right? So you need to find out the matrix inverse of matrix A. So you guys need to tell me what is the inverse of matrix A. Either you do it using a built-in library or you do it manually, but please tell me what is the inverse of matrix A. If someone has access to Python, they can just do it in Python and let me know what is the result. Or if you are doing it manually, that's also okay. Well, the coordinate matrix will be that matrix only, so it will be V equal. And what will be A inverse into A? Can anyone say?
Identity matrix.
Identity matrix, right? And here you will be doing A inverse in B. Identity matrix multiplied by any matrix will be that matrix only, so it will be V equal to A inverse B. So what you have is V is equal to A inverse multiplied with B. We already have the matrix equal to A, and here you will be doing A inverse in B. Identity matrix multiplied by any matrix will be that matrix only, so it will be V equal to A inverse B. So what you have is V is equal to A inverse multiplied with B. We already have the matrix A. So first of all, what we need to do is we need to find out the inverse of matrix A, and that is on you. Please do it rapidly and tell me what is the inverse of matrix A. Matrix A you already know, right? So you need to find out the matrix inverse of matrix A. So you guys need to tell me what is the inverse of matrix A. Either you do it using a built-in library, or you do it minus 17.
Minus 2.
Matrix B is, so what we need to do is to find out the matrix V, we need to multiply A.
Honestly speaking, I'm not getting a lot of things in my head as compared to this. I was like getting a lot of things, learning a lot of things from here, but not a lot of things from here. Yeah, those were my honest answers. I could have finished all of that today, but I messed up, I guess. But I think we did both of these. I believe these two are completed. I can jump into this. For matrix multiplication, I can just see the problems. If it's doable, then it's fine. And these are some very interesting problems. I should solve these. Now I really got this. Um, for honestly, for primers, um, till I know what is this. Oh, this is differential equation. Fine, fine. Um, I will go slow. Like in even in linear algebra, we just have to do that only. I will just do probability and stats from here, probably. Like not from here, honestly, because they only have two. Yeah, 2 and 3 maybe. Oof, this shit is interesting. Oh, all right, no issues. I had targeted I will finish till what 11? Uh, till 9 to 11 was my target. Um, this is 11th only now. Okay, this is 11th actually. So I will do it anyways. And I will do system of. I will just double down on the problem solving part now because I need to solve some good problems. I will try to do it from some of my physical books. Um, okay, I won't really put in a lot of hours in it, but tomorrow I will have a session where I will just solve questions of part A and part B till 11. Okay, what these linear equations systems actually have. Okay, write 3/3 system of equations with no solutions where all the planes are parallel, where two planes are parallel and the intersect them, where the planes are all different and intersect the line. Okay, Okay, so this is just okayish kind of examples. This would be something that we should double down. So first we write this in the matrix form. Call all coefficient matrix A. First we check determinant of A equal to 0. Okay, so this is minus 6 not A. Yeah, first we check the determinant if it's not equal to 0. I wrote that in my note or not. Probably not. I will just write it. Inverse I don't know why, but this MIT scores feels a lot easier to catch up, a lot more. It's a lot more in depth, so it's probably good. But I need to speed up. That's the only problem. I think one whole day, if I give it to this thing, then I can just solve this. So the here dot cross and dot vector components are kind of useful. Cross is useful, matrix multiplication is useful, inverse of the matrix is useful. Then I came to solution to square systems. This is important, and probably that's it. That's all we need from here. Then we can just jump to probability. Okay, if we have to find the inverse of the matrix, then 1 by 1 by 1 by of its determinant into it adjacent into adjacent of determinant. Okay, start with homogeneous case. X equals to 0. Okay, okay, consider system of equations. Write the system in matrix form. So 1 2 3 4 5 6 7 8 C 7 8 C, and then XYZ, and then 1 2 3. Okay, for which values of C is there exactly one solution. There is exactly one solution when coefficient of the matrix has an inverse, that is uh, invertible. This happens when determinant is non-zero. So we just have to figure out the determinant here. So the determinant is um, Here determinant comes out to be C. Okay, there's exactly one solution as long as C is not equal to uh, 0, not equal to 9. For which values of C there are either 0 or infinitely many solutions. uh, this is this complement part of B. There are 0 or infinity many solution when this is equal to 9. Okay, take the corresponding homogeneous system for which value of C found in C give all the solutions. So if it is the homogeneous um, solution, we are looking for vectors xyz that are orthogonal to each other, each of the rows of A. Since determinant A equals to this, the rows are all in the plane. Since determinant A equals to the rows are all in the plane, and we can find orthogonal vectors by taking a cross product of first two rows. Okay, so if we just take the cross product of these two rows, then it, yeah, comes down to this. Yeah, it's correct. I just cross checked. Since scaling will preserve orthogonality, all the solutions are scalar multiples, that is, all the solutions are of the form xyz equals to this and this. Yeah, so we can make this a little nicer by removing the column factor of the 3. Okay, okay, let me first check. I'm just um I just uh, uh yeah, brought my book, algebra book, and from here probably we have matrix part. I can't see determinant. Okay, here is determinant. So in determinant only we have system of linear equations. Yeah, solution of the system, homogeneous linear equations. Okay, we have that part. So I will do questions from um, that part. And do we have system of equations? And here we have inverse. Okay, fine. We can do various operations on matrices. I will just mark out what I have to do, and I will just do it. So inverse row operation, I will see what I can do. I will do session 4. I will do this thing, system of linear equation, Kramer's rule. Okay, okay, it's fine so far, but ha haven't we haven't studied eigenvalues here. So won't we study eigenvalue? So this wasn't something really hard, or oh no, that's something else. Yeah, so I will just give it a so Let's take c equals to 1, find all the solutions. So we will convert this into matrix, check it's 0 or not. So the inverse exists, and they and can be used to find the unique solution. We don't actually need to compute the inverse because we know uh, yeah, this is 0. Fine. The coefficient matrix is now this. Yeah, we check for determinant and it's 0. Since determinant 0, there are infinitely many solutions to the homogeneous system. We find them by taking a cross product of two rows. Cross product of two rows. Okay, we did cross product of this. This is the answer. Therefore, all the solution are of the form. This is the XYZ here. Okay. So what I think is not there was nothing uh, very unique here. And what's here? So um, this is basically from geometrical point of view, as the instructor told earlier that they will teach everything from geometric algebraic slash geometrical point of view too, and it's really interesting. So the problem will show the multiplication by matrix. This is the matrix. X by rotating vectors 45-degree counterclockwise. As usual, we write the vectors uh, as this. Show that the length of this is same as length of V. Um, okay. Okay, this is kind of complicated, but it's fun. So if we have to figure out the length, what we can do? Okay, AV equals to 9 meter of V makes sense. Using the expression found in E dot, e dot V we found in the part A, we compute the dot product. EV dot V. Okay, yeah, it makes sense, I guess. So we have lastly we have to find the compute the cross product. So since the coefficient of k is positive, the right hand rule tells us AV is counterclockwise from V, and this is really interesting. Okay, I think I can do the I mean yeah. Let's see, equation of planes isn't that important honestly, but we will see linear systems. What is this? Okay, this is same now where we have to find the equation where for parallel uh, one intersection. Yeah. So what's left here? We haven't seen equation of planes, and it is not necessary to. Um, did we have we seen this thing? Inverse of the matrices. I don't know. I'm not sure have we seen this or not. So let's just see. Um, find inverse of this. So to find inverse of this, we compute the determinant of the matrix and matrix of cofactors and the adjoint matrix. So So first find determinant, then find minus. Okay, I was just mentally finding minus. Okay, I got it. How to find minus, minus, and then for cofactors we just have to switch the sign. So plus, minus. So if you start from plus, then plus, minus, plus. That would be convention, right? Or it's starting from negative itself. I don't think it's starting from negative. It should start from positive here. So yes, I think we can just move to this. Okay, how do we find adjoint? How do we find adjoint? So this is important, right? How the hell we are supposed to find the adjoint? So okay, adjoint is just like, yeah, these are, I have to check it once. Okay, so adjoints are just a rotated version of um, cofactors. Is it cofactors, right? So let's say adjoints, here adjoints are um, 20 minus 5 7, and this side it should be 20 minus 5 3. Yeah, so adjoints are uh, just interchange version of rows and columns from cofactors. I was just doing this here. Yeah, you can see. So I think I can move ahead. um, so we just have to figure out uh, like determinant. Like I saw a formula somewhere. So if we just see the formula, then it would be uh, 1 by this, 1 by determinant of the adjoint. So as easy as that. So I will just write the formula. So formula for inverse would be 1 by determinant of A into adjoint of A. And we can find adjoint by here. We can find adjoint by, adjoint is nothing but uh, rows and column interchanged. from cofactor. That's it. That's what a joint is. So honestly, we are done with this, and I think I understood more in just 20 minutes from MIT's course as compared to that video, bro. So I will just do one for one day, for tomorrow only. I will just do problem solving for these things, and then I will jump to this thing. I will just show you. I will jump to this. Okay, I'm honestly excited for this, and this week 2 would be interesting. I will try to complete this week 1 as soon as possible, honestly, but let's see how it goes, honestly. If I just see, um, what should I see? It's long. I mean, if I want to complete this quickly, I have to do like 3 weeks together. Probably 3 weeks, yeah. Probably 3 weeks together. And basically, I'm just interested in these two things. If I solve this, oh, no, not really this, but okay. Okay, was I solving? Yeah, so basically, if I solve most of the problem, or if I really understand most of the problem, I can solve those things. Also, I have to see lecture slides of. I have to really watch probability in a focused way. So I think I have like 27 classes. Let's keep 27 classes even if it's for review. Then let's say I'm doing two classes, two, three. Okay, let's pick a number three. Three classes in a day. So I will be finishing this in 9 days. So yeah, that would be good. I will set a target to finish at least three classes in a day with proper understanding. So again, if I see the calendar, yeah, I can finish this thing. So I think every week do have two classes. So um, so finishing three classes in a day uh, will definitely be tough, but I'll try. So just a prerequisite, we just finished the prerequisites, like it was basically vector determinants and matrices. And I think I think I have done a lot more in those 20 minutes than than whatever I was doing here. Okay, for math section, I will definitely do most of the things from my MIT, and I'll do most of the things from reading resources here. So I will just try to go through the reading resources for most of the thing. Like hypothesis testing is really important, and we really need to like study this. So yeah, this would be fun. So I think we will mostly cover Z test. Like if Z is the hypothesis testing, then we will mostly cover this in our probability and stats, I believe. Isn't it? If I see lecture classes, I think Z test and everything like that comes under these things only. I don't know if I'm wrong or not, but yeah. Um, so should I just start with first class? I will just read the first class. Uh, if these slides. Okay, let's read slides of the first class. Yes, very excited to start this. Can't we just zoom it or something? Because okay, I will just download it now. Let's download it and then read it. It will be much, yeah, it is much more clear. Here we go. Okay, I will keep the slides like this only, and I will make a proper section for probability. So let's just start with basics, and I will keep this. I will keep this here. It it looks fine. All right. So what is active reading? Read the calendar information. Before classes, reading and reading questions. Okay, reading questions count towards grade lecture. We assume you are done reading. In class, combination of lecture and problem solving. We won't assume you have completed mastered the reading. We will assume a level of familiarity. Okay, so we should make a structure like how should we read. So how should we complete probability, because probability is important. So we will just follow this before class. Reading questions, we will do this before class. um, Base instructions. Well, normally I will follow this norm, like the same norm. in all of the MIT courses. Kind of just bring it back. Okay, so first we will do, I can just paste it. So before class, reading questions, reading and reading questions. Then I can do, so this is what I have to do before class. And then um, before class reading questions, um, can just make it in one line. Then I will read lecture slides, lectures, problem sets. That's it, I guess. And after everything, solve questions from wherever. Okay, so this is the methodology that I will follow. Okay, looks it looks okayish. I can just move ahead. Okay, should we do this too? I don't know. Okay, this is platonic ties. This is 4-sided, 6-sided, 8-sided, 12 and 20-sided dice. Okay, probability of stats, logically self-contained. A few rules for computing probabilities. One correct answer. Messier and Moore of an art seek to make probability-based inferences from experimental data. No thing. Okay. What is probability of getting exactly one heads in 3 tosses of the few coins? Okay, let's see. If if we have half probability of getting in one, so half into half into half, so that would be 1 by 6 now. I think 1 by 6, getting one head in 3 tosses of this is for one fair toss, this is for two fair toss, three fair toss. So we will what is the probability of getting exactly, so we have three situations: heads or tails. Either it will come head or tail, either head or tail, either head or tail. We have 6, so even 6 in 1 will work. Or if we write 6 in 3, then the answer would be 1 by 2. No, so it would be 6 in 1 only, I guess. And let's just ask AI what it thinks. What do you say? So Okay, it's coming out to be 3 by 8. So does it got explained? Um, Probably not. Okay, let's just understand this. What is the probability of getting one hits in three tosses of a free coin? Okay, there are three independent tosses. The probability of hits is 1 by 2. What exactly one hit? The formula is 5 independent yes and no trials. Okay, it wasn't that complex, but yeah. Wait, wait, what I really did? Didn't I had the same thing? Uh, this is 1 by 8 now. I missed that. I missed that simple equation. Okay, I was on the right thought process, but I wasn't completely right. So how you can think it is interview? Okay, we can have a thought process like this. Okay, think how many places can the success go? What's probability of one arrangement? And multiply them. For this problem, the places for head was 3, The probability of one arrangement was this. Okay, I think we should note all of this, whatever comes. Uh, I will just write it in basics for now. Okay, let's see what's next. Deck of 52 cards, so 13 ranks. Yeah, 13 ranks, 4 suits, poker hands. Consist of 5 cards. One pair hand consists of 2 cards having 1 rank. Okay, the remaining 3 cards are having 3 other ranks. I didn't understand this thing in a very clear way. So, one pair hand consists of 2 cards having 1 rank, and remaining 3 cards having 3 other ranks. The probability of one pair hand sets in words. Old New English rule, don't eat clams on shellfish in months without R, as equals to all months month. Okay, basic set operations. Okay, inclusion, exclusion principle. If you want to include everything, this is inclusion. Then A plus B, and have to exclude the overlapped part. Okay, makes sense. A band consists of singers and guitar players. 7 people sing, 4 play guitar. So we have to plus this 2 minus this, right? 11, so it will be 9. Example: 3 shirts, 4 pants, 12 output, 12 outfits. Set of shirts into set of pants equal to set of outfits. So if we take magnitude of this, so it would be okay. Concept question: DNA is made of sequences of nucleotides A, C, G, T. How many DNA sequence of length 3 are here? No, honestly, they have really good questions. And do I have to watch video? I guess right now. Um, I can probably close this, and if I go to reading materials, can I just go to class 1 and watch the clip first? Or there isn't clip? Nah, that would be not good if they don't have video lectures, because video lectures are important. I can say lecture notes I can't see lectures. Okay, I really can't see lectures here. So, where actually is lectures? Do we have lectures of this at? So, MIT 18.5. Okay, let's see what's there. Can we access the lectures from here? So, probably we don't have lectures, we just have in class materials. So, main thing here are in class problems and solutions. So, actually, there is, it makes, I mean, no such sense to go through all of these. Uh, we can skip slides or we can just skim through slides and just, if we read this, we are good to go. We can solve the problems. Because I just went through these reading materials and they were good. So if we just see online reading questions, okay, it actually redirects me to that. Uh, Not this, but this was very contentful. This, yeah, this was very contentful. All right. So I was just figuring out what should I do. I will keep this tab open, close these tabs. So yeah, I think we should start. So I have to prepare a to-do list because this will be my last study session for today. Because it's Sunday, I want to keep it a little light. I have to focus on these things too. This thing especially. I have to see how I can even jump through this, and I will just look around this. Um, so for 29th, I will write it in this way from today. So for 29th, I have to matrix determined questions and probability. Probably I will do probability. Like I will just get my foot onto probability. So I will try to do first session of first class class completely, and then I will have the so this I will do in one session, this and this thing probably I will do in same session. I want to read some finance things. um let's say what I can read. I have probably two options. Even if I don't go that deep on finance, I have probably two options. I have to figure out C++ classes. I do have some C++ CP. I do want to learn C++, but the problem with me is I can learn with lectures. So I have to figure out or see. Um, I have to figure out a way from where I can learn from this thing. We have 9 lectures. Wait, not line, not 9. 1, 2, around 16 lectures. So I will try to just see and experience the first lecture, how it goes. Yeah, this would probably be tough, but I want to learn because I have to do some CP. So this is very important. So even if I learn these things, I can just I can just good to go, I guess. Okay, there was nothing in this first course. In this first session, there was nothing to adapt. There was that one, the studio one code, like studio.h. That was the only thing that we can take from that course. And yeah, this would be good one. So int, double string, boolean, true, and size. C++ static type language. So yeah, we have to define everything here. More examples of typing. Enter say. Okay. Okay, I will start from this session 2 tomorrow. C++. I will just keep it light in first day, and from second day onwards I will just like go deeply. I will just give C++ link here. Once I have proper hold over this, I will just start with the problem statement that I have. Tomorrow will be a little tough on this side, like a little heavy on this side, and probably a little light on this side. So this I can do in morning session, this I can do in probably midday session, and for night session I want to revise everything, and I can work on the project that I undertook. Okay, so probably that's it for, I guess, today's study session. I haven't studied much today, but whatever I studied it deeply, so it was fine. I will just end the broadcast. Where do I end it?